So I don't have any presentation, so we just go through the assignment. So what we do is we will run SciLac, one set of experiment, and then we have a data set from label free, then we will have a TMT and a TIMS TDA data processing. So we start all four. Right, so I usually have a shortcut in the taskbar so that it's easier to just click and then the MaxQuant opens, and then if you have multiple MaxQuants, you can just right click and then open, so it's much more easier. Right, so let's start with SciLac dataset. So the first tab is where you add the raw data, and then here you can either say load or load folder, and usually for the raw data from demo files you can say load and load folder, but load is easier. Then we can just click, go to the data, practical 1, SciLac, and then these two raw files, right? So these are the two raw files that we have in, and that's the size and data format. It's actually kind of reading it, and parameter groups and experiments. So when we have no fractions, what we can do, just say no fractions, and then it's automatically cutting out the common string and then just writing out experiment names as 1 and 2. Right? And in general, I would say not to write 1, 2. It would be better to write, say, set experiment, and then instead of 1, I would usually write 0, 1. That's because if you have like 30, 40 samples, it will be like 1, 2, it's 1, and then 11, 12, and then 19, then 2, 20, like this, because it's like considered as a string, so it should be labeled 0, 1 so that the columns are correctly ordered in the final data set. So it would be nice if it's already 0, 1, 0, 2, like this. I
Zoom in, please.
Try. Oh, cancel. It's better? Yeah. Right. So this will be then 2. This is just a, it doesn't look like a phospho, it's a SciLac proteome. And it's not a phosphoproteome, so it's a PTM is we set to false. So that's the default, and then we set, yeah, question. Any PTM. Yeah. Any PTM where you're actually interested in the quantification of PTM in comparison with the proteome. Yeah. It will, no, this is for the occupancy calculations, right? So there is this occupancy calculations done when you have phospho, for example, let's take phospho, and let's say you have 5 files that are proteomes files and 5 files that are phospho-enriched sample, right? So then for the 5 files which are phospho-enriched, you will set that to true, because then it knows that this is phospho-enriched and that is the proteome file, and this information is used to say, to calculate occupancies. So for example, if we have 100 molecules of the protein, how many of these particular protein molecules are actually phosphorylated? So these kind of occupancy calculations are done. For that, you need this information. To really search for phospho, this doesn't really matter because you will set the modification in the next tab. So.
Here. What if we didn't enrich the sample for the PTMs, but we still want to look for the...
It's possible. You can still...
Can we say false or true?
Yeah, false, yeah.
Okay, thanks.
Right, so let's say I did all the other settings, but let's say I forgot to put the experiment names, and then I started the run, it finished. What actually happens? It's all in one thing. So but then you don't have to completely start from the beginning. I will show you later how to do that. So for now, no fractions. I keep it 1, 2 because it's less than 10 samples, so it doesn't really matter. So, and that was the load option. Load folders, you can load the whole folder. And what I do, in case the files, so let's say you're opening a previously used parameter, yeah.
Can you just clarify again when PTM column is true versus false?
So when you do a PTM study, you should always also do a proteome study so that you know the changes in the PTM is coming from PTM and not from the proteome. So then you will analyze the proteome and the PTM together. In that set, all the files that belong to the proteome will be set to false in this column, and all the files that actually come from the for PTM enrichment that will have true. Does that make clear? Good. So in case the files have been moved, then what happens is here exist would be false, and then we just have to select this change folder and look for the folder and then select the folder. So then this will turn back to, so let's say for now I say this is in desktop. I never did that, so. Okay, yeah, so it's like this. And when it is false, because it's not existing in the folder, you can go and select the particular folder, so where the files are. Yeah, and so in this case, this is no fractions. I think we will discuss the parameter group a little bit later. Yes, so if you want to change this, then if you want to set the PTM, so you select the file and then you have to set the PTM and then change the value. And then it becomes true. But here it's not the case. Good, then we move to the group specific parameters. And here we only have one group, that's group 0. Therefore, we actually have only one set of group parameters. And the type is where we actually set what kind of quantification we are doing. So standard is kind of, well, how should we, this is standard is where we start with all the thermo-raw files. And then if it is multiplicity 1, it means there's only one channel. So if it is multiplicity 2, then there is heavy and light channel, right? And if it is multiplicity 3, then you have heavy, medium, and light channels. That's the way you set for the labels. And here this is heavy and light, so the multiplicity should be 2. And the light labels is actually lysine 0 and arginine 0, so you don't have to set anything here. And in the heavy label, this is arginine 10 and lysine 8, right? If for some reason, for some other weird reason, you had some other amino acids in the light state, then it has to be also selected here in the step. Zero, yeah. It's label free. Okay. Yeah. This doesn't set that to label free, but for label free, this has to be 1. Right. Right. So this is Silac sample, so we set that to 2. Lysine 8 and arginine 10. Right? And then digestion, in this case it's trypsin, and the maximum mist cleavage is set to 2. That's the default value, and we can just leave it in that value. And here in the digestion mode, you have specific, it could be semi-specific and with free N-terminus, meaning the N-terminus is kind of degraded or N-dragged peptides. It could be semi-specific C-terminus, or it could be both and semi-specific or unspecific and no digestion. So, but in this case, we use specific. Right? Can you see that? Yeah. So modifications here, the default values are oxidation of methionine and protein N-terminal acetylation, and fixed modification is carbamidomethylation of the cysteine. And this is the maximum number of modifications per peptide is set to 5. So for example, not more than 5. In this case, it's not relevant. Right. That's then label-free quantification. In this case, it's none because it's a SILAC. Yep.
Sorry to go back to the modification question, but since this is false for modification on the sequences page,
Yes.
so this is for
The
identification.
files.
Yeah, so PTMs. So on the modifications that you were just on, that's for identification only?
It's
Whereas
identification. For example, if you would choose phospho in this case, it will also write out a phospho STY dot this sites table. You can use that, but you are not doing this occupancy calculation. Can you explain? So the question was, if that is set to false, if the PTM is set to false here, and here now we add phosphorylation as a modification, it will still write out the tables, and the only difference is it's not doing occupancy calculations, right? Using a proteome file.
so that would be for identification purposes only here on this page.
In this page,
I see.
yes.
Okay.
Yeah. So, but let's take it out. Label-free quantification is none. Yeah.
So, in case of TMT experiments, what happens to N-terminal acetylation? Is it identified or?
That's protein N-terminal acetylation,
Yeah.
right? So the initial protein N-termini would still be searched as acetylation, yeah, as a variable acetylation modification, yeah. So here.
I have a question about occupancy calculation. So, for instance, yeah, of course, we have to have the proteomic file and the phosphorylation files or phosphoproteome files. So, let's assume that we have a very, very short time frame phosphoproteomic study, and we have multiple time points for phosphoproteome, but we do not have as many time points for proteome. Because yeah, for phosphorylation, we are also measuring at minute or seconds level. So is it possible to calculate the occupancy, or we always have to have for every single time point all these phosphoproteome and proteome files?
I don't know how the calculation is, but anyways, the proteome is not going to change in 5-10 minutes, but I don't know. You need to have match samples. So you actually need to have match samples. For proteome, also at different time points, the very short time point.
Every single time point has to have both proteome as well as phosphoproteome files.
Phosphoproteome. But can you just take the same proteome and then fake it? Or copy the raw files, yeah. Yeah.
Couldn't you just take the pass-through of the phosphocapture resin?
Sorry, what? Can you please?
Could you just save the pass-through in the phosphocapture resin and use that as your proteome file for each time point?
You could. It's not perfect, but you could, yeah. Right. So no label-free quantification. So first search is to have. So you can actually do the first search with a different data, with different modification sets and enzyme, and the different enzyme for the first search, but it's not required. But let's say there is a pull down done, it's a protein pull down, and then you're interested in the interaction partners, and there is no phospho enrichment, but you're also interested in the phosphorylation on the bait, then maybe for the first search, you don't have to include the phosphorylation, and then the main search, you can include the phosphorylations, and it's actually faster, but it's not a big deal. So you don't have to set this. And in the miscellaneous, we have requantify, so you have to check the option for requantify depending on when you want the requantify options to be switched on. And yeah, let's leave it like this. Then we move to the global parameters. So requantify is if you have SILAC and heavy and light, and let's say you only found the heavy peptide, and then after identification it knows this is the heavy peptide, so it will look into the light region to find a ratio. So it will take the noise or any signal that's coming from there, so that you will get a ratio and not like a missing value for the light channel in this case. Okay, so we add sequences. This is it's east. Oh, yeah. Okay. Is that okay? So the FASTA file, because of this naming, it's automatically getting the identifier rule and the description rule. And by default, you include the contaminants, minimum peptide length, it's 7. And question? And the maximum peptide mass, it's all set to default values. So then we move to the identification tab. So all the false discovery rate is now set to 1%, PSM, protein, and site. This is set to 1%. And this is the standard settings for minimum number of peptides, minimum number of razor peptides, and minimum score for modified and unmodified peptides. Yep. Oh, sorry. That is this in your in the data in the FASTA folder. You will have this 55 92 92. That's the yeast FASTA file. That's the one you use. Right? So in the identification tab, we leave everything to default, and this is where just what Shivani was talking about, the dependent peptides can be selected, but it's irrelevant here at the moment, so we are not using it. And yeah, so if you want to have match between the runs, between these two files, then we click the match between the runs option. So by default, this is also off. And we can leave the default parameters as such. Right? And protein quantifications for the label. So in this case, it's SILAC, it's a label, and then the minimum ratio count is set to 2, meaning if the number of quantification events is less than 2, the ratio is not reported. So for example, you will have intensity values in heavy and light channel, but the ratio will be NaN. But you can also set this to 1, so which means for also ratio count 1, you will get ratios, and you can later filter them in Excel or Passairs. So then you can decide for the peptides that are used for quantification, would you use all of them? Would you use unique and razor or only purely unique? And so it's case by case basis, you decide this. And this is the thing. So like all the modifications which are not PTMs under study, which are chemical modifications that happen during sample prep, for example, these modified peptides will be used in protein quantification. If it is not in the list, let's say you have done phospho enrichment, you have added phospho here, And if you have not added this here, then oxidized methionine containing peptides and their unmodified counterparts will be included in the protein quantification, but the phosphopeptides and the counterparts will not be included in the quantification. Right? Right, so then we can go to label free, which does not apply here, so we can skip this. And tables, so this is an option. Most of the people would not want it. These tables, anyways, it's not useless. So then it's by default off, but if you're looking into all these tables, then
Can I ask a question, if you don't mind? The previous study that in protein quantification, there was an option that peptide quantification, unique, razor, or all. And can you explain those options, which one to choose, or in what case we should use which?
So
Thank you.
let's imagine, so the protein can have peptides which are either unique to them, or maybe there are some peptides which are shared between different proteins or protein groups. And some peptides are unique. Come on, I'm repeating this. So you might say, I'm only interested in the unique peptides that are present in that protein, and I would like to use only those unique peptides to for the protein quantification. Then you will select unique, right? And if you want to use unique and razor peptides, which are, let's assume it's unique like, then you say it's okay. So then you will use unique and razor peptides. But I think generally you will never say all peptides. I mean, you will have anyway some unique or razor peptides to quantify. But I think there could be cases where everything is possible. So let's say a protein is identified with 16 peptides. Of the 16 peptides, 10 of them are unique to that particular protein. The remaining 4 peptides are shared with other proteins, right? So these 4 proteins would not be used. That's the meaning of when you say use only unique and razor peptides for quantification. Let's say there are like 5 isoforms, and then so some peptides are really common to all the isoforms, and then you don't want to use them for quantification because you want your isoform-specific peptides for quantification. Well, this depends on whether you actually identify these peptides, depending on the sequence coverage. So we did cover tables, and this is, we don't have to touch. This is just the search parameters for different, all kinds of analysis. It's kind of it's already optimized. And folder locations, so for example, if you have a very slow hard disk, but I think these days it's not an issue anymore. So the read and write speed is not one of the limiting steps. So if it was a limiting step, you can have a temporary folder location in a, say, faster hard disk, and then all the temporary files are written there and read from there. So that process is faster. And if you have files from multiple locations, maybe you can, and is that correct? Then you can select the combined folder location, or? Yeah. And let's say, for example, yeah.
Finish what you're doing. I was going to ask a question on intensity determination on a different tab. So finish what you're doing first.
Okay. So for the fixed index folder, so let's imagine we are using.
My question was going to be, if you have a solid state drive, do you want to
Yeah, you could
add
use
that
that
in the list? Okay.
Yeah, yeah. So if you have unspecific search, and so then if for peptidome analysis, then the step of actually preparing search might actually take long. And if you use exactly the same parameters every time with different files, then what we can do is the MaxQuant creates this search folders, and that can be reused. So this preparing search step can be skipped. It's not skipped, it's directly reading from this particular folder. So that way you can, every time you do that same search, you can skip that particular step and then save some time. So that's the fixed Andromeda search folder, which you also have here as a description. And if you have that, then you can select that folder and this is used. So maybe we take your question with the, something with the intensity.
Yes, on the group-specific parameters in the instrument, the last line item is intensity determination.
It's,
Default is value at maximum. Is that based on the
That's what
the
the-
apex peak height?
yes, I think this is what you described in the morning, right? So if it's taking the peak value or the extracted ion value, yeah, so that the default value is at the peak.
And would total sum then be the total of the peaks in the MS peaks defining that extracted ion chromatogram in the MS scans only?
I don't know, maybe. It's integrated over the elution profile. Yeah.
And then there's two others, formula, weight, half height, sum. I guess that would be essentially half the
I think it's, yeah,
integrated value.
essentially not the whole thing, but maybe just the full width half maximum of the whole elution profile.
So the default then is peak height.
Yes.
Okay.
Okay, so this we don't have to touch. This is also we don't have to touch. And then in the advanced, there is only one option that I would like to show, is that you can select the calculate peak properties if you really want to get a lot of additional information in the tables, especially spectral properties. This will add all those information, but this also comes at a small additional step, which also adds up some time. Right. And before we start this, we can also say how many threads we want to use. Let's say for now we say 2 threads for this particular process. And if we have multiple different windows of MaxQuant, we can just rename them. This is like SciLac 3A practicals. Okay, and then we can start this. Yeah, because the file is not existing because I was moving around the folders. So. Good. So can we move to the label-free quantification? Any questions? Yeah. Yeah. Okay, so then let's start with the label-free. So we load the files. So this was this 3B label-free proteome. And we selected the files. In this case, these are 2 pull downs and triplicates. So again, we can just say no fractions. Again, it's taking this common string and then adding this up. Okay, so I think here it's all good. Then in the type, this is standard and multiplicity is 1 because there is no labeling. And digestion, it strips in, same thing. Modifications, same. And then in the label-free quantification, we say LFQ. Right. So then, so default value is 2, but I would like to use like 1 so that it's reporting more LFQ values. It's like something like ratio count 1 in labeled samples. And so we can actually skip normalization, but this is in very special cases, so we do not touch this. Again, the instrument, everything is same. It's all the same. So that's the only difference there, that you have to say it's an LFQ and not SciLac. So here, add files. This was
Naga, can you repeat again and be slow?
okay. Sorry. Right from the beginning of the label free? Yeah. Okay. So for the label free, I loaded these files. They are in this practicals 3B label free proteome. So I loaded all the files. Right.
When you're loading the FASTA files, I learned by Braille that I could name the files with a default, a unique base name for different experiments or replicates, but then put underscore rep1, rep2, rep3. And it automatically kept track. I didn't have, if I wouldn't have to group things. I mean, I left, of course, group 0 for a standard binary LFQ. But I think, can you also, if the names are not, file names are not that way, then you have to do set experiment. You select them and you give them a name.
Yes, and if you have many files, what you can do is just write template that writes out a tab delimited file. So yeah, we can do that. And then in the folder where the files is, then there is this experimental design file created. And then it's, if you open this with Excel, it's probably easier to just type something and then just drag, then it's easier. All right, so if you have many files, you can just name them here.
So along the same lines, if you have, say, 7 samples with triplicates, so 21 data files, and you've named them, just put rep1, rep2, rep3. So for set experiment, you would want to take those 21 and name them, say, control. And then if you have another 10 or 12 in triplicate, that would be a separate set, and you would say set experiment and name it experimental or something else.
So you
Right.
will say control 1, 2, 3 for the, or like, so you mean like 7 replicates of 3 conditions?
Well, if the data files had unique names for the, say, patient, but rep1, rep2, rep3 for reps, and then you say you have 3 or 4 of those, so 9 or 12 of control, let's say, and then you have another set with the same kind of thing for the experimental or the diseased or whatever. So if you highlight the ones that are control and then do set experiment and then name that, you could call that control, and then it would know those 2 groups exist that way. What I'm saying is, if you don't name them properly so that it automatically knows, does that override that automatic sorting?
I think I didn't understand that, but one comment is, if you select all this set of files and say if it is control, it will think it's all one experiment control. And you will get a single quantitation value for that. All 7 files, you will get one value because they all get collapsed as one experiment.
Oh.
So if you have unique names for the samples plus rep1, rep2, rep3, then it will automatically, it will automatically give this unique names plus rep1, unique name plus rep2. So that will automatically do it. So it doesn't even need to know that these are replicates and these are replicates. I mean, because this you will anyways take it up in Perseus.
Okay, afterwards in Perseus, you can always set
Yeah.
the groups.
Yeah.
I see.
Right. So this case, in this case I clicked no fractions because it's systematically named. So then we have all the names. There's no PTM, so it's all false. There is no calculation. So the type is standard and multiplicity is 1 because there is only one set of labels. I mean label free. Then digestion, we use the standard settings because it's trypsin, so we leave it as trypsin. Specific and maximum is cleavages is 2. Modification, we use the standard. Then we have label free, and this is where we actually change. So previously it was at none, and we select the label-free option, and we select the minimum ratio count as 1, just like, but here you actually cannot post processing, you cannot filter them. I don't know, is there any way to filter them? No, you cannot filter them. So if you are interested in having a ratio count of 2, then you actually have to reprocess the data. Right. So in the ratio counts for the SILAC, I mentioned that you can say minimum ratio count is 1. And then if you want later, you can filter the data by saying ratio count 2, using that criteria. But here, there is no way to figure out what was the ratio count in the output tables. So if you want ratio count 2, you have to reprocess the data. Right, so that's the only difference. And then instrument remains the same. This remains the same. There is no meaning of requantify in label free, so we don't have to touch that. And first search is the same thing. Then we go to the global parameters. Yep.
Last tab, why did you, oh sorry. On the last tab, there used to be an option to change the match type for match between runs. Why is that no longer in the newer versions?
Because it's not really functional, because when you match, you can match from and to. It doesn't really matter if it is only 2. So we remove that functionality. So it's always bidirectional now.
If you had a library sample you wanted to match from, it can...
But the library will be added as anyways as an evidence and MSMS table, right? You mean the library as raw data or?
Yeah.
Yeah, because then it's also matching to the library, but it doesn't matter, right?
At the raw data step, you said to have replicates. So I wonder why didn't you use the parameter group to set the replicates?
The replicates are all in one set of parameters, because this is kind of one experiment. So let's say if you have 6 files, these are the, let's imagine in a situation, these are the 6 pull downs, and you for some reason want to also analyze the input material of your pull down, the 6 input material, then that's slightly different, and then maybe you want separate LFQ for them, then that is a separate parameter group. So this is a single experiment where everything belongs to that single parameter group, consisting of many different sets of replicates.
So in which state will I need to use the parameter groups to set one from another?
For example, let's say you have these 3 are proteome and these 3 are phosphor samples, and this here you want to select phosphor as a modification, and in the first 3 you don't want to. So then you will select these 3 as one group and these 3 as set parameter group to 1. So it's starting from 0, so this is the 1. Then let's say in the last 3 files you want to search for phosphor, then you can separately mention this. In this particular group, I want to include the modification of phosphor. But in this case, it's not true.
So just to be clear, so if I have, let's say, 3 different patients, all the same sample, I wouldn't do parameter groups?
They all have single parameter.
Okay,
they have the same parameter, let's say. Yeah. So before I forget, I changed the parameter groups.
Oh, another situation for different parameter groups would be your totally different gradient. You stretched it out quite a lot, so you don't match between runs there, except for in a small group.
The parameter groups would not define the matching between the runs. It's only the fraction numbers that define the matching between the runs. So if you have, let's imagine that in this case, the next 3 samples had something wrong and then their elution profile is completely different, and you don't want to match between them. So here you would say these 3 are fractions 1, for example, and these 3 are fractions, say, 3 or 5 or something distant, so non-continuous. Then there will be matching between these, within these 3 files and then within these next 3 files. There will be no cross-matching.
Okay. Thank you.
Searches for peaks and neighboring fractions.
Yes. Two distant fractions, so there should not be, yeah. Yep.
This is more for a SILAC, but that requantify option, when should that be used? What considerations should be made when doing a SILAC experiment?
So when you have extreme changes and then one of the channel is not found, then the ratio is not reported, right? So if you're only looking into the ratio, then you miss that because it's an extreme change, but you miss when you look at the ratio in column. So in order to avoid that, maybe you can do the requantify option.
All right, thank you.
There was a question here. So.
So if you were to do a pre-fractionation reverse phase high pH and you combined every eighth tube, what would you do there?
That sounds like a feature request. Yeah. They have to make linear fractions or circular fractions. Okay, so here it's the same, so we just have to add the database. This is the east. Was it east? No.
Human, Naga.
Human? Okay, good. Thanks. And then I will not press start. So. Okay, so every other parameters we leave as it is, and then match between the runs. We select match between the runs. That's in identification. And protein quantification, it's again the same thing. And so there is labeled free quantification. So this is labeled free quantification, but and then here is, if you have two different parameter groups, then you will have, can you see here? You will have separate LFQ in the parameter groups. So in that case. And so IBAC is, I think we discussed yesterday, because it's kind of normalizing the intensity to the identifiable peptides to give a rough abundance of the protein within a sample. And if you want that value, you will select that. Okay, so that's the thing. So in the label free quantification. Yeah. Yep. Question here.
If I use two different sequence database, not the database, but two species, like one is Homo sapiens and one is something else, the protein group table still shows one group table, and the FDR is calculated based on both sequences together?
I think depends on, there should be a split protein groups by taxonomy. Yeah, the FTR is calculated together, but then there is an option. Is it in the public version? There should be an option for split protein groups by taxonomy. No. If I can find that. Don't see that. Maybe in miscellaneous.
Quantification, maybe.
Yeah, but I think there is an option. So if you want two separate tables, you can do that. I cannot find that option now. It's the separate LFQ actually for the parameter groups, but it's not then splitting the protein groups. It's not there. Yeah. Gone.
I normally combine the FASTA file in one FASTA file. Is that the right thing to do?
So this is also doing the same thing. Like if you put two different FASTA files, it's combining them. So.
Okay. Thank you.
So we move to the TMT maybe. There's one question here.
It's kind of specific, might be beneficial to others. Let's say I have a few samples and I know I have a priori knowledge that they are different, heterogeneous, and I want still do relative quantification. Should I be changing one of the default parameters or just leave it as it is?
Could you please repeat the question?
So I have a few samples, let's say 5, and I know from an RNA experiment, for instance, that they are very different in the terms of gene expression, and I expect the protein to be different. But I still want to do label-free quantification. Should I change one of those default parameters or just leave it as it is?
I think if it is too different and so maybe one possibility is MaxQuant will give an error saying that it cannot do the LFQ. But if it is going beyond that and then giving the LFQ, you can just look at the data and then do a post normalization somehow. You can use that. Right?
Okay.
In the label-free quantification tab under global parameters, there's a require MSMS for LFQ comparisons. If you only have MSMS identification for, say, one replicate out of 10, will you still get LFQ values for each of your 10 replicates?
So it's not for each of the 10 replicates. It's for each pair, there should be at least one MSMS. So when you do the initial pairwise comparison to look for before at the very beginning of the LFQ process. So it's not that in the overall, if it was only one MSMS, probably would you get LFQ values in many? No, right?
But it's exactly in these pairwise comparisons, right? Then it would only do pairwise comparisons between a pair where at least one of them is having an MSMS.
Yes.
Yeah.
Yeah.
But would it do that one file with a pairwise comparison against the others at some point so that you would be able to get that ratio?
So I think you will have LFQ value only in that sample 10 then, or no?
So you have LFQ values also for samples where you don't have an MSMS for this protein. It just means that when you go through all the pairwise comparisons, it will actually not compare samples where none of the two have MSMS for this peptide, right?
Yeah.
But that still can happen that you get quantification for all of them.
Okay, yeah, thanks.
Yeah, so this is only relevant if you have match between runs, because if you don't do match between runs, then every feature has an MSMS on top, right?
Yeah. So then we move to TMT. So then load files, this should be 3C TMT, the 4 files. And these are independent experiments, right? So these are not fractions. So no fractions, so then there are 4 independent experiments. And then here, group specific parameters type, that's where you change things. This is reporter ion MS2 based quantification. Then 8 plex, 8, yeah.
Just before you go ahead, is what you're about to explain reporter ion MS2 the same for reporter ion MS3 for TMT? Or is there anything different additionally that we need to take into consideration?
Similar.
All the same. Thank you.
Okay, so in this case, it's 8-plex TMT, so we just select that. Right? And then, so here's, so filter by PIF, this precursor ion fraction, this option. So if you say yes, then you can, okay, if it is anything less than 0.75 in the precursor ion fraction, isolation fraction, then that is not used in the reporter ion intensities are not used for calculation. Right? And then there is a variety of parameters that you can, additional filters you can set, minimum base peak ratio. So if that is a very low peptide that was selected from that particular spectrum, you don't want to see that. And yeah, but this depends. So I'm not an expert in TMT, so I don't know what values are good. Yeah, so usually there's no filtering by default. Okay, so the digestion remains the same. Modification remains the same. There's no label-free quantification. So we can just directly go to global. The only difference is this is mouse, so you will actually select the mouse FASTA file and start the search. Right? Okay, so can we go to Tim's data? So actually for the TIMS, the raw files are actually .d files. If you check, because they also, in Windows, they also look like folders. They are actually folders. And so these are the raw files. So in order to load them, you will say not load, but load folder. And then you browse to that folder, which is desktop. You just select the folder which actually contains all the .d folders. And if there are subfolders which also have the files, then you will click recursive, but in this case it is not. So if you click, then the three .d folders are loaded. And in the data format, this already says it's a Bruker TDF file format. That is the file format we are loading. And again, these are 3 different files. There is no particular fractionation, so we can say, fraction, just take, in this case, it's now taking, it's a bad example of, so when the file names are not so great, then it's like taking these as experimental names. So we can just simply say set experiment sample 1. Set experiment sample 2. Right? And the only change to be done is, in this case, group specific parameter type, and then we choose TIMS DDA. And everything else is the regular label-free quantification. That's the only change. So then you will say label-free quantification, LFQ, again 2 or 1, depending on your taste. And we can leave all the parameters default, and then select the FASTA file and start. So, any question?
Just a general question. So if you go back to the load raw files, I think I recall in the older version, it is possible to just name all the experiment at once. Like you can name like 1 to a certain number. It's not possible.
That
So
was
we
the
have to
fraction, I think. You're talking
not
about
the
the fractions.
experiments. Okay.
Fractions. I show you that. Question?
I understand that that when you do match between runs with multiple fractions, that it looks at neighboring fractions when you designate them in the raw files page here. But what I was wondering about was, how do you do the retention time alignment if the matrix of each fraction is going to be slightly different because of its elution profile that may affect the retention time significantly? So if you can imagine, you identify it in fraction 4, 5, and 6, but another set you identify it in fraction 3, 4, and 5. What the matrix of 3 versus 4 would be significantly different. Maybe there's a 10-minute retention time shift. That would be really difficult to catch.
So the alignment of retention time is actually not looking at all at the experimental design and at the fractions. So it's actually independent of this, determining the alignment order. So the alignment order is determined by some dendrogram. So it's doing some clustering on the samples, forgetting completely about experimental design and fractions. And then it's using this clustering to determine the order. So that means it just takes the 2 most similar samples in your run, in your MaxQuant project, and aligns them first. So it doesn't ask what this is, if these are same fractions or not. So it would actually, because of that, it would do everything right, basically.
Okay, thank you.
Right, so then, yeah.
Sorry, could you explain in the global parameters advanced tab, what down at the bottom of the list, there's this use series reporters, MS2 precursor, mass shift. Can you say what this is?
No, I don't know. I make this big. No, it doesn't. So, use series reporters. Is that something for easy tag or global advanced at the bottom?
My question is if that is in relation to TMT on an MS3 readout, if this plays a role or not.
Very specific option for quantification with complementary ions. So in particular, this easy tag quantification that we saw, because so the easy tag has the property that actually all the Y and B ions are multiplied by the number of channels that you have. So actually, so if you do 6-plex or whatever this easy tag is, then you suddenly have 6 Y3 ions.
Ah, okay. And that doesn't
Then
happen.
the question is if you should use that for quantification or not, basically.
Thank you. Yep.
This one here.
Well, I have a question about the instrument parameter. So for example, if I use 6K for the select data quantification, but I use 500K for the new code select quantification, so is that necessary to change the instrument parameters to improve the quantification accuracy for new code?
I think when you, in the type, you select new code, it's automatically changing things. So you don't have to worry about that. So for example, in the type, if instead of saying, if you say new code, the MaxQuant knows that it's new code active, so it's automatically looking for the right resolution parameters in the instrument specific parameters. But I don't think you can combine 2 different types at the same MaxQuant at the moment. So you will run them independently. So normal label free and a new code, you will run them separately in the MaxQuant. Okay, so I just thought, okay, so if we have to do an unspecific search, maybe what are all the parameters we will change? Maybe we can just go through that. And then I'm done. So let's imagine, yeah, so I load these. I have this folder called fake fractions because the 6 raw files from this LFQ pull down, I just copied them 2 times. So then each file is repeated 3 times. So then we can label them as fractions 1, 2, 3 just to see, I think, but you know that. I think you get the point. So I don't think we have to do this. Sorry, what? So this is something which you don't have in the stick. So this is just the same LFQ files, the experiment 3B. I just copied the 6 files so that the same file is repeating now 2 times, repeating 2 times, so total 3 times. So then we can say this is actually experiment 1, but then these are fractions 1 to 3. So you can set like this. That's why I just wanted to show you this. Right, so that's one thing. And then last thing is, if it is actually unspecific, so then the only thing you will do is in the digestion, you say unspecific. And in the global parameters, you choose the database that you want. And then it's actually using this particular parameter. So it's, can you see this? Minimum peptide length for unspecific search and maximum peptide length for unspecific search. It's like 8 and 25. This is what it's using. So depending on your project, you know what to search for, and then it's taking the time according to that. That's one thing. And then maybe if you would do that, then maybe you can set protein FDR to 100%, because it's not a protein level analysis. More questions?
Okay, if no more questions, we need to move on to the next session, and thanks to Nagar's tutorial.